Today's learning objective is I can find the slope and y-intercept of the slope-intercept form y equals mx plus b of a linear equation from a given linear table. In this activity, we're going to start by thinking way back to your 7th grade math class when you were doing your Moving Straight Ahead book, where we had two brothers, Emil and Henry, racing. So in the Pear Deck slide right now, go ahead and see if you can figure out what's happening based on this table. You can pause the video and type in the student-led Pear Deck. You'll start to notice, if you haven't caught it from the Pear Deck, that at time 0, Henry is 45 meters from the start line, and Emil is 0 meters from the start line, meaning he's on the start line. So you can see that Henry has a head start, and as they go, you can see they're running at sort of different speeds, and eventually, at time 30 or 30 seconds, they have the same, and then Emil takes the lead. So looking at that graph here, how can you see the same information in the graph? And on the Pear Deck, you can go ahead and circle where you see things, or if you want to type the letter T, it will allow you to text and you can write whatever you want in words. So go ahead and describe or circle where you can see the same information. How can you tell that Henry has a head start? How can you tell where they both meet? And how can you tell who is ahead at the end? You can pause the video, take a look. You can see right away that Emil, right here at time 0, is at the start. Versus at the start, time 0, Henry is up here. So he clearly has a head start if you think of the time or the distance in meters. And where the two lines intersect is the time and distance that they both are at the same place. So this is where Emil starts to pass Henry. And at the end of the race, you can see that Emil is farther ahead, just like in the table. So which is easier for you to read? For some people, the graph is easier. For others, the table is easier. You can go ahead and type your response in the Pear Deck. And why do you think one is easier than the other? Next part is we're going to look at this graph. Now we have for the last week been working on writing equations of graphs. So let's refresh that and see if you can remember how to find the equation of these two linear graphs. So take a moment, see if you can do that. Again, you can pause the video as you type that in the student-led Pear Deck. Remember, when we're trying to find the equation, we're finding two pieces. The y-intercept, the b, which you can find at 0, 0, and at 45, about halfway between 40 and 50. You can see this grayed out line is halfway between 40 and 60, so that would be 50, and the blue line starts halfway between that, so 45. And the second piece you need is how can you find the slope? Remember, in the slope, you can start by picking 2 points on the graph that you know. So for Emil, maybe right by this E would be a good place. So at time 0, we go from 0, we rise up to 50, and we run over to 20. So then we have 50 divided by 20, which is basically 5 divided by 2, and we get 2.5. So our slope is 2.5, and our y-intercept is 0. Henry's a little different. So Henry starts at 45. Again, we find 2 points that we know for sure. Well, maybe this first one here and the second one here. And so Henry's rise, we go from here up. We're going from 50 to 60, so he goes up 10. And then he goes over from 5 to 15. So he goes over from 5 to 15, which is also 10. So his slope is 10 over 10, or 1. And you can write that equation. So y equals 1x plus 45 for Henry, y equals 2.5x for Emil. Because we were adding 0, we don't really need to count that. So how do we do this if we're given just a table? From a table, you still have to find the y-intercept, and you have to find the slope. Go ahead and pause the video and take a minute. How do you think you might find that? So we got the two parts again. If we're trying to find the y-intercept, the first place we're going to do is we're going to start at the x values, because we need to find where the x value is 0. And the x value is 0, that's telling you you're at the y-axis. And then we just need to look at the numbers that represent that. So for Henry, 45, and for Emil, it's 0. Two different y-intercepts. When we get over here, we can look at, now we need to find the slope. Now that's a little trickier, but since we know it's linear already, because if we're looking at the table, you can start by looking at, does this have a constant rate of change? And the way we find constant rate of change is we check again, we start with the x values, right? We're looking for the change in x. So this is going up every time by 10, by 10, by 10. And then we go to the y values, and we look at noticing again, well, going up by 10, by 10, by 10. So if we have constant change in both, then we know that our value is linear. So in the table, in this case, we can really see it's linear. We already knew it because we saw the graph, but if we didn't, we could go up. Every time I go up by the same amount, I'm going up by the same amount in y-axis. Similar, when we go to Emil, he's going up by 25 and 25 and 25. So again, every 10, I'm going up 25. So we have a constant rate of change. And then we can look at that just like we did in the graph, 10 divided by 10 equals 1. And in this case, we're only looking at these two distances here. And so we're looking at 25 over 10 versus with Emil before, we were looking at 50. And so again, you could look at any two sets of points. So if we looked at the points that we looked at on Emil for the graph were 0 to 50 and 0 to 20. So we had 50 divided by 20 and also would get 2.5. We get to put them all together. So if we have that 45 and 0 for their y-intercepts and our 1 and 2.5, then we just substitute those values into the equation. So now you get to try. So go ahead and take a moment to practice. So you can go ahead and pause the video. And if you're in class, we would do this with your breakout partner. But if you're at home alone, go ahead and give it a shot. And in this one, you're going to go ahead and start by looking at, well, I'm telling you it's linear, so we're going to go from 2 to 4, which is 2, and from 60 to 100, 40, 4 to 6, which is 2, 100 to 40, also 140, which is also 40. So we have this constant rate of change, and we can keep looking, and it's always going up by 2 and going up by 40. So to find the slope, remember we look at the y value first, so rise over run. So 40 over 2 would be 20. That would be our slope. And our y-intercept, we'd have to work backwards here and go back 2. Since every time we went up 2, we were adding 40 down here. We would go back 2, we would subtract 40, and we'd be at 20. So our equation in this case would be y equals 20x plus 20. Right? 60 minus 40 is 20. All right, try again. Next one. Now this one's a little different because our values don't seem linear, but in this case it definitely is linear. We'll have to look at some values in between. You can pause the video and give that a shot. So in this one, we're looking at 2 to 3, which is a change of 1, and 3 to 7, which is a change of 4. And 7 to 11, which is a change of 4 also. So we can kind of compare these two. We'll see if theirs are the same. So going from 2 to 3, one value, and we're going down by 30. We go from 3 to 7, so 330 to 210, we're going down by 120. But we have to divide that by 4. So 120 divided by 4, oh my gosh, is 30. Similarly, if we go from 210 to 90, 210 from 90, it's also going down by 120. So again, if we divide that by 4, because from 7 to 11 is 4 units, we would also get a minus 30. So now we know our change in y for every 1 unit is going down by 30. And our change in x for every 1 unit is 1. So our slope in this case is minus 30, or a negative 30, because we're going down every time. So what's our y-intercept? Well, again, we got to be careful, because the 0 is here, but we don't care about what the y equals 0. We want it about x, which means, again, we have to go back. In this case, we have to go back 2. And since for every time we go up 1 on x, we go down 30, then when we go back 1, we're going to go up 30. And since we have to do it twice, we're going to add 60 to 360, which is going to be 420. So your y-intercept would be 420, and your slope is negative 30. And you put that together, y equals negative 30x plus 420. All right, hope that makes sense. I got one more for you, and I'll let you work that one out on your own. Please email me or come to the async time if you have questions.